Yeah, now you can start. Good morning to all. Welcome to this course on engineering thermodynamics. So I hope this is a new learning process for all of you because normally we are familiar with the classroom teaching and you all are familiar with the learning in the classroom while sitting in the classroom, interacting with the faculties, discussing your queries. Okay. So this is how we have been learning till this time, but due to this pandemic situation caused by COVID-19, we have to now go with the different ways in order to continue our teaching learning process. So what we will be doing, particularly we will be having very short duration semester for all of you in order to make up for that time, whatever has been like wasted. So therefore, we will be having very short duration semester. Considering this short duration, this particular lectures have been planned to be completed within the 2 months. Okay, so we are having planned to cover 40 lectures for this particular course, Engineering Thermodynamics, and these 40 lectures are to be covered in a span of 2 months only. So it means every week we have to go for at least 5 lectures. Okay. Moreover, we will be having very different process of learning, like we will be studying by online mode, and at the same point of time, whatever your doubts and queries, etc., will be there. These will be also taken care of using the online mode. Okay. So what I will do in this particular lecture, we will not have very much detailed discussion on our subject. Rather, we will try to see that what we will be doing in this course. Okay, so what are the learning objectives of this particular course? Why this course is important for all of us? Okay, and how this course will be executed. So that is what we will be doing in this particular lecture. So that's why I have kept the title of this lecture as Introduction to the Course. Okay. Then next, what we are having. Yes, someone was saying something. Okay, so what will be happening in this particular course? I am Pramod Kumar. I am assistant professor in School of Engineering. So I'll be your instructor for this course. Okay. And my email ID is also given over here. So if you are having very, very specific queries, in that case, you can also contact me via email. Apart from that, I will be having one associate teacher with me for this particular course. His name is Mr. Pushpendra Kumar Shukla. He is a PhD research scholar in School of Engineering. So he will be associate teacher for this particular course. Okay. And now let us try to see the syllabus for the course. So in this particular course, what we are having, can you all see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. So will you share this?
Okay, fine.
Yes, sir.
So this is the syllabus for the course. So first let us try to see LTP. So LTP is nothing but lecture. Please keep your microphone muted. All of you, please mute your microphone. Okay, so if you see LTP for this course, L refers to lecture, T refers to tutorial, and P refers to practical session. So we are having 2.5, 0.5, and 0. It means that in 2 weeks, we will be having 5 lectures and one tutorial. So after every 5 lectures, we will be having one tutorial session. That is, if this runs in regular semester mode, where we will be having only 3 lectures tutorials per week. Okay, but in this particular semester, as we will be having 5 lectures per week, so we are expected to have one tutorial session every second week. Okay. Now, what we will be doing, mostly the course is actually very conceptual, and at the same point of time, these concepts will be having significant applications. So we will try to do this with the help of numerical problems. Okay. Now, in this particular syllabus, we are having first introduction lecture. So this is whatever the lecture I am taking now. Then we will be having next lecture, next particular module on fundamental concepts. We will be spending around 2 lectures over there. Then we will be having next module on properties of pure substance, where we will be spending something around 3 lectures. Then we will be having first law of thermodynamics. So here we will try to devote a majority of our time, something around 8 lectures we will be devoting over here. Then we will be having energy. So this is our first law of thermodynamics only, but it is applicable to open systems. So here also we will be having something around 3 lectures. Then we will be studying about second law of thermodynamics. So second law of thermodynamics is actually very, very important, because it tells the concept of association of with energy. So here we will be spending around 7 lectures. Then we will be having very, very important concept of entropy and exergy. It is a very important performance of the systems. Okay. So there we will be having something around 3 lectures. So this is up to this entropy and exergy, we are having actually the more fundamental portion of the subject. Okay. After that, what we have to do, obviously, every subject is having its applications. Okay. So once we have studied the fundamentals, by employing the knowledge from fundamentals, we will try to devise some systems which will be actually doing some desired desired functions, whatever we want to achieve from these systems. Okay. So for that, we will our cycle is nothing but the devices with the help of which we can convert heat energy into some useful work output. Okay. Then we will be having air standard cycle. So in case of air standard cycle, our working medium is air. Okay. And here what we try to do, we try to once again convert heat energy into mechanical output, some work output with the help of some arrangement. Okay. Then we will be having our last module on refrigeration and air conditioning. So obviously refrigeration and air conditioning is itself a course if particularly you do your bachelor's in mechanical engineering. But for others, like because refrigeration and air conditioning is also an important aspect of engineering. Moreover, if I talk about the thermodynamic systems, you will be finding that majority of the applications we are having in our household appliances, these are based on the refrigeration and air conditioning systems only. Okay, so that is like our last module. Here we will be having very brief discussion on the refrigeration systems. Then we have our textbooks for this particular course. So I have included 2 books, Wortnick and Sontag. So this is on fundamentals of thermodynamics. So this is the main book which I will be particularly following for this course. Of the whatever I will be discussing in the lectures, essentials and goals also, thermodynamics and engineering approach. So this is also one very, very important book, and it's very good book actually. So what you can do, you can study this book also, because in this particular book, you will be finding the examples from our daily life situations. Okay, so whatever we see in our surroundings every day, you will be finding that the concepts are introduced in this particular book by considering these examples. Okay, so what I will be doing for
Sorry
some
to
of the
interrupt.
topics, I will be following this particular method.
Sir, sorry
Yeah,
to
please.
interrupt you, but my screen is showing that you are sharing the you are starting to share the content, but not showing the content.
You may once disconnect and join once again because it's visible to others.
Okay, sir. Thank you.
Okay. Okay. So what we will be doing, as I majority
क्यों क्या हो गया
content, I'll be
सोनू जी का तो
discussing
नहीं
only
है
one
ये
thing.
दोनों का कुछ
Please
लोग क्या
mute your
गई
microphone.
कुछ याद नहीं मेरे को पर नहीं इसमें
All
नहीं
of
चलता
you,
सोनू जी
please
वाले पे
mute
नहीं
your
चलता
microphone. Okay, so what we will be doing for majority of our content, we will be following only these two books. Apart from that, there are more books also given over here. So at the moment, because this is a very fundamental course, so you need not to go to many number of books. It's a good idea to go with a single book when you are actually studying the fundamental subject. Okay, so you can refer any of the book, either Sontag or okay, so this is up to your choice. So whatever the content I will be discussing in the lectures, you will be finding that majority of it is actually taken from any of this book. Okay, now comes the very important part. Whatever we study, after that we are having actually evaluation. Okay, so in this particular course, what we will be doing, what I have considered at the moment, that I will be giving you something around 8 to 10 assignments. Okay, so you may expect that every second week we will be having one assignment. Okay, and what you have to do within a time period of around 1 week, you will be given around 1 week period in order to complete that assignment, and at the end of you have to actually submit that assignment. So assignment submission we will be doing via Moodle only. So in the Moodle there will be some link will be created. Okay, and you have to then upload your assignments using that particular link. So for assignments, I am giving very less weightage. Okay, so because the purpose of assignments is to make the concept understand. Okay, so means whatever concepts we will be studying in our lectures, assignments will be based on these only. Okay, so if you are solving the assignments, you will be getting better understanding of the concepts. Because of that, I'll try to give majority of the means a number of assignments so that you are getting a good clarity about the subject. Okay. So for assignments, I have kept 10 marks. So probably each assignment will be having weightage of around 1 to 2 marks. Okay. So after that, another evaluation strategy I have considered over here that we will be having multiple quizzes, something around 5 to 6 quizzes of 10 marks each. It may be of 10 marks or it may be of 15 marks. Okay. So the idea of having the quizzes, continuous number of quizzes is that this will be actually, if someday someone is having some connectivity issue. Okay. So he'll be losing like very less number of marks only. So because of that, what will be happening? We will try to do more number of quizzes and we will try to give a weightage of around 60 marks. So all these quizzes will be done in online mode only. And as you are aware that we have to complete the final grading for this course by the mid of February. So that's why we have to also conduct the final exam in online mode only. So for final exam, I have given the weightage of 30 marks. Okay. So this is now at this particular whatever I have thought of. Now what we can do, obviously, while we will be going through the course, so in between, if we are finding that something has to be changed, we may update a few things also. Okay, so obviously the changes will not be major. So small changes if we need to do, then we can actually slightly deviate from this particular evaluation scheme, whatever I have specified. Okay. Now, this is like all about the content, whatever we will be studying, and what textbooks we are having and what evaluation scheme we will be following. Now, let us try to see some understanding or some introduction about our subject thermodynamics. So now let us a little bit go into the technical details of the subject. Okay. So now let us try to see a brief introduction to our course thermodynamics. So the name of the course is thermodynamics. Okay. So thermodynamics is something. Please mute your microphones. Okay, so of energy. Okay, so this is like we can the fundamental definition of thermodynamics. So what we do, if you see in your things, we are having large number of energy systems available. Okay, for example, we are having our ovens, etc., where we convert electrical. Okay, we are having automobiles where we convert the energy stored in the petrol or diesel. So that energy is nothing but stored in the form of chemical. That we are having engine as our device where combustion of the fuel takes place. So by the process of combustion, chemical energy of the fuel changes into heat energy. Once we have received or got the heat energy, then we are having some mechanical arrangement, particularly a slider crank mechanism, where our heat energy gets converted into nothing but our mechanical energy. Okay, and that mechanical energy then with the help of some gearbox or drive shafts actually is being taken to the wheels. Okay, so this is nothing but overall this is a process thermodynamic cycle where we are actually converting one form of energy into other form of energy. So that is the whole idea of thermodynamics. It is something which is known as the science of energy, and this particular subject deals with the systems involving storage of energy. So the systems where we are having storage of energy and conversion of energy from one form to another. Okay, so two important things are involved over here. We are considering about energy. We are concerned about energy. So we are dealing with the energy and we are dealing with the storage of energy, because if you are having a fuel, in the fuel energy is stored in the form of its chemical energy. And second component, we are having nothing but conversion of energy. Okay. So this is like the fundamental definition of thermodynamics you all can consider. Then what we have now comes that when we study a subject, we slightly go towards the historical background of that subject. That what is the history of this subject? Okay. So if you see the word thermodynamics, it is actually combination of two different words, therm plus dynamics. So the first word is something which is referred mainly to heat, and second word is mainly referred to force or power. Okay. So historically, thermodynamics was only known for conversion of heat into power. So that is how the historic idea of thermodynamics started. And the very first concept of thermodynamics has evolved somewhere in 1697, where first steam engine has come into picture. Okay, so we all know about steam engine. So where nothing but we are employing some coal for converting water into high pressure steam, and that high pressure steam then we are expending on some expansion device. We are having some mechanical arrangement to convert that pressure energy of the steam into nothing but our mechanical output. Okay, so there was one engineer, Thomas Savy. He has actually first come up with the idea of steam engines in 1697, and after him in 1712, one more modification to steam engine was suggested by Thomas Newcomen. So from there, the idea of thermodynamics has come, where it was the basic idea of their work was to conversion of heat energy into mechanical energy. Okay. After that comes the first and second laws of thermodynamics. So both these two laws were actually simultaneously evolved. So these has particularly come somewhere close to 1850. Okay. So in 1850, these two laws of thermodynamics has come. So particularly what happened? There were three scientists who parallelly actually have come up with all these laws of the thermodynamics. Okay, so first scientist I am referring to over here is Rudolf Clausius. So you all might be knowing from your earlier knowledge of that we are having some Clausius inequality in our second law of thermodynamics. So that inequality was given by Rudolf Clausius. Okay, then we are having one more statement associated in our second law of thermodynamics. That particular statement is known as Kelvin-Planck statement. So it was originated from the initial work of Lord Kelvin. Then we are having one more scientist, Professor William Rankine. Okay, so these were the three different scientists from whose work we have actually got the birth of first and second law of thermodynamics. Okay, so out of these three, Lord Kelvin was the first person to use the term thermodynamics. So the term thermodynamics was first used by Lord Kelvin, and the first textbook on thermodynamics was written by William Rankine. So William Rankine has written the first textbook on thermodynamics, and this textbook is written in 1859. Okay, so Professor William Rankine was professor at University of Glasgow. So he has written the first book of thermodynamics. Okay, so now this is all about the historical background of the subject. Now let us try to see some of the applications of the subject thermodynamics. Okay, so what are the application areas? So if you see thermodynamics, you will be finding that it is everywhere around you. Please keep your microphone mute. Okay, so you will be finding, for example, if we talk about our kitchen itself, inside our kitchen we are having a refrigerator. Okay, we use refrigerator to preserve majority of our foods and vegetables. So that refrigerator is nothing but based on the principle of conversion of energy. Okay, we are transferring heat energy from one location to another location. So that is nothing but is an example of thermodynamic system. Then you are cooking food over the stove. Okay, so that stove is nothing but once again an example of a thermodynamic system. Then apart from that, if you talk about please mute, keep your microphone muted.
उनको वोट करने की यार। तो मिस्टर एक यहाँ ये लिखवा दिखाइए
Okay, so like I was telling you that we are having large number of applications. For example, if we want to maintain comfort conditions inside our room, so for that what we are having? For that we are having nothing but air conditioning unit. Okay, so our AC is nothing but once again the example of thermodynamic system. We all are using electricity, and because of the electricity only we are able to now attend all our lectures, because your laptop, whatever you are having, that is requiring electrical power. So that electricity is coming from some thermal system where we are having steam power plants, where we are actually burning huge amount of coal in order to convert water into high pressure steam, and then that high pressure steam is actually being employed to obtain the electricity. Okay, so it means anything you see around yourself, you will be finding that everywhere thermodynamics is involved. Okay, so that's why the subject of thermodynamics, though at this moment it may appear to you that okay, it is of relevant only to electrical engineer or only to mechanical engineer. Why I am being a computer science student studying this subject? Okay, but the overall idea of the subject is that it's a very, very fundamental subject, because it is having application in our surroundings itself. Each and every system, whichever we could think of, is somehow related to the thermodynamics. So that's why it's a subject which each and every engineer should know. Okay. Moreover, when we specify any of the governing laws in our practical systems, in order to define the practical systems, so we may take this broad classification based on the general laws and particular laws. So what we have in case of general laws, we can write down some principles of fundamental physics which are applicable to each and every system, whatever we are having in the universe. Okay, so for example, if we talk about conservation of mass, so conservation of mass is something which is applicable to each and every system, whatever we could think of. If I talk about next thermodynamics law, law of fundamental physics, we are having nothing but Newton's laws of motion. Okay, so once again, these are the general laws which are applicable to each and every system. Then we are having one more law. If we talk about law of conservation of energy, so whatever the system we could think of in our surrounding, in our universe, everywhere we will be finding that we will be having applicability of law of conservation of energy. Okay, so the subject thermodynamics is a subject which deals with these particular general laws. For example, in thermodynamics, our majority of the discussion will be on energy. As I have already told you, this is a subject which is based on the law of conservation of energy only. So that's why we can categorize the subject of thermodynamics under the category of general laws. Okay, so general laws is something which are the very, very fundamental, applicable to every system of the universe. So that's why this is very, very important for all the engineers. Okay. Now, if we talk about particular laws, in particular laws, we can come up with very, very specific laws which are associated to very specific type of systems. Okay. For example, if I consider that I have a metallic rod, okay, and one end of this metallic rod is actually heated. and other end initially it was at nothing but ambient temperature. So what will be happening? If we are heating one element, one end of the metallic rod and other end which is at ambient, so what will be happening? We will be having flow of energy from heated end to the end of the rod which is at ambient temperature. Okay. So whatever the heat energy we are getting at this one particular end, that heat energy will be actually flowing in this direction. Okay. And as this is a solid metallic rod, so inside this rod, what will be happening? If I have to apply that, what will be the rate of heat transfer? Okay. So first I have to identify that what is the mode of heat transfer over here. Because rate of heat transfer is something which is significantly controlled by the mode of heat transfer. So in this metallic rod, we will be having nothing but what type of mode? We will be having conduction heat transfer. Okay. So because of that, if we have to identify that what law will be governing this phenomenon, which law will be giving us the rate of heat transfer, we have to specifically use the conduction heat transfer equation. Okay, so I have to use Q equal to minus Ka into dt by dx. So I have to specifically use our Fourier's law of heat conduction. This point is clear. So this is nothing but our Fourier's law of heat conduction. Now, if I talk about another situation where I have a metallic container and this metallic container is completely filled with liquid. Okay. Once again, within this liquid, we are having actually at the left face of this metallic container, we have heat. In the right face, we have nothing but ambient temperature. Okay. So we have low temperature. So what will be happening here also? Because what is the mode of heat transfer within this liquid?
Convection.
Convection, sir.
Convection.
So don't confuse. Generally, convection comes only into picture when we are having actually the bulk motion of
Fluid.
liquid. Okay, so flow. In this particular system, we are not having any flow. So because of that, here also our conduction mode of heat transfer will be working. Okay, but if I slightly modify the problem and if I now consider that I have a pipe, this is nothing but a heated pipe. So from the periphery of the pipe, I am adding some heat and now fluid is flowing through this pipe. Okay, so now what will be happening? This particular fluid will be taking the heat from the surface of the pipe and now this fluid is under actually bulk motion. So because of that, now what will be happening? This particular arrangement will be having nothing but which
Convection.
mode of heat transfer?
Convection.
Convective mode of
Convection.
heat transfer. Okay, so because of that, if I have to define the rate of heat transfer over here, I have to use which law? Newton's law of cooling. Q is equal to H into AS TS minus TF. Okay, so this is what I have to use. So from this typical example, you can clearly see that while we are applying the heat transfer rate equation, this heat transfer rate equation, what it is doing basically, it is applicable depending upon the mode of heat transfer, whatever we are having. Whether we are having conduction or we are having convection, depending upon that, we have to select the equation and we have to apply that equation for finding out that what will be our heat transfer rate. Okay. So this type of laws which are specific to the phenomenon which is happening inside a device, These particular laws are something which are referred to as particular law. Okay. So thermodynamics is a system which, thermodynamics is a subject which deals with general laws rather than particular laws. This point is clear. Now, let us try to see one more example. For example, if I have a system which is maintained at say 250 degree Celsius, okay, and I have one more system which is in close contact with this particular system, and say this second system is having temperature of 100 degree Celsius. Now we are considering that in between both these systems we are having nothing but a perfect contact. This point is clear. So if we are having two different blocks which are in perfect contact with each other, and one of the block is having temperature of 250 degrees Celsius and another block is having temperature of 100 degrees Celsius. So what we will be finding? We will be finding that from the high temperature is 250 degrees Celsius to 100 degrees Celsius, we will be having in this particular direction nothing but flow of energy. Okay, and whatever energy that will be flowing over here, that particular energy is known as heat energy. Okay, so why it is called as heat, that we will try to see in our subsequent lectures. So in this case, what we will be having nothing but transfer of heat from high temperature system to low temperature system. Okay. Now, what will be the mode of heat transfer over here? That is something which we will not be able to get from the knowledge of thermodynamics. How much time it will take? That is also something which we will not be able to know from the knowledge of thermodynamics. Okay, then what amount we will be having, that is something which we will be able to determine from the knowledge of thermodynamics. So the idea is that thermodynamics is something which subject which deals with the systems at equilibrium. Now, in more details, we will be able to know from our subsequent lectures, and it doesn't give us information about that how that process is happening and how much time this process will take. Okay, so thermodynamics only tells us about absolute amount of energy interaction that is associated in a system. Okay, this point is clear. So already I think you are having only 5 minutes left for your next class. So I will stop at this particular point, and I hope that with this you people might have got idea of the course, idea of this subject, what it is about, okay, and what mainly we will be studying over here. Okay. Now what I will do, we are having some doubt clearing sessions also scheduled. So particularly, I don't think so there is any need of doubt clearing session, particularly for today's lecture. Okay, so we will try to do the doubt clearing session from tomorrow onwards. For doubt clearing session, we are having two different strategies. Either we can split all the students into small groups, and we can have doubt clearing session for each group. Or another strategy could be, I'll be circulating online Excel sheet. In that online Excel sheet, you all can write your doubts, okay, and these particular doubts then will be visible to all. Whoever feels that he is having the same doubt, they all can join to doubt clearing session. Okay, so like which mode we will be following, what I will be doing today, I'll circulate a Google form. So all of you please respond to that Google form. I'll be giving you some deadline also. By today only you have to respond to that Google form. So based on the responses, I will select what mode we will be using for our doubt clearing session. Okay. And I feel that today, as we are having very, very fundamental discussion only, so there is no requirement of doubt clearing session. So probably tomorrow only we will, from tomorrow onwards only, we will start our first doubt clearing session. Okay. This point is clear?
Yes, sir.
So now,
Can you please explain how the other method of doubt clearing will happen?
in first method, you will be split it in small groups, and group wise, you will be having one session per week. Other method is I will be circulating an online Excel sheet. In that online Excel sheet, you can mention all your doubts. Okay. Now that sheet will be visible to everyone. Now, whoever feels to join for the doubt clearing session, they can join. Okay.
Okay, sir.
Doubt clearing session will be counted as tutorials or something else?
No. Tutorial will be separate. Doubt clearing session will be separate.
Okay, sir.
All doubt clearing
So what
session
I will
necessary?
do today, I'll be circulating a Google form. So now, based on your inputs in that Google form, then I will decide the strategy. Okay. So now I am stopping.
Necessary.
at this
Sir,
point.
sir, tutorials will be on random dates decided by you, or will there be some fixed schedule for tutorials?
That will be fixed schedule. From 10 to 11 only we will be having tutorials. So in the lecture hour only. Okay. So some of the lectures.
Okay, sir.
will be next tutorial.
So where can we get the recorded video?
I will upload the recorded videos on Moodle.
Okay, thank you.
So will you
All
upload the
the all the
previous
reading
PPT also?
material, whatever all the reading material will be uploaded on Moodle. Okay. So by today afternoon, you can see everything will be there available on Moodle.
Doubt clearing session necessary.
Why not?
If you feel you are having doubt, you join for the session. Okay.
Sir, what is a tutorial?
In tutorial, numerical problems based on the fundamental concepts will be discussed. Okay. Numerical solving. Basically numerical solving, problem solving.
Then doubt clearing only teaching. Oh, sorry. Doubt or teaching will also be there.
No, it will be only doubt clearing. Okay, so I'm stopping at this point.
Thank you, sir.
Thank you.